Next, I'm really pleased to introduce Nick Gagbani. So I think many people know that video surveillance, whereas in augmented reality, we're kind of wondering when it's going to be deployed at scale. In video surveillance, that's an answered question. It already is deployed at scale. But what we're wondering about is when is computer vision going to be effective in video surveillance? And I can't think of anyone better qualified than Nick to address this question from a practical point of view. Nick's been involved in computer vision for video surveillance for many years, since way before most of us even thought of the connection, and before that in many other kind of deployed computer vision applications. So Nick, welcome. Thanks for coming.
Thanks, Jeff. Can you guys hear me? All right. Okay, so great segue from the previous talk, which was fascinating, and you'll see why as we go through this. And when Jeff asked me to give this talk, he's absolutely right. I mean, video surveillance, there are more video surveillance cameras deployed in the world than most other types of cameras, excluding cell phone cameras, which overtook that years ago. But they collect a lot of video that's continuously recorded, and that creates an opportunity to clearly analyze that video and do more with it. And the question is, what are we doing today, and is it sufficient? All right, so let's jump in. And so for a lot of you folks, it presents an opportunity potentially. Real quick about CheckVideo. We have the longest commercially deployed video analytics. Video analytics tends to be a marketing term used by the surveillance industry that talks about the use of vision to solve problems pertinent to security and some retail applications, which we'll talk about. But we have been doing this longer commercially than anyone else since 1999. And if you've passed through any major airport in the United States, you have benefited from our technology. And today, our cloud-connected cameras generate about 2.5 million events a day. So since I started speaking, we probably went through about 10,000 video detections across our network of cameras, right? We've been doing this for a while. CES 2009 and 2010, we actually had smart home cameras with advanced vision incorporated and won some awards, pretty cool stuff. And more recently at the Security Industry Association Security Products Magazine. So that's who we are. But we are the guys that deploy cameras in mostly commercial environments, critical infrastructure, airports, things like that. Why should you care about this market? I mean, we're all in the business of creating solutions, applications, and tool sets for vision. Why is surveillance important? It's important because it is a big market. And I think you had some stats on the total number of video surveillance recorded, which was about 500 million. Maybe a little low because there are about 300 million cameras deployed today worldwide. They're in operation, right? And they are producing video continuously, and in large part, that video is being recorded almost continuously, or certainly when there's any kind of change in the scene, right, which is called motion-based recording. And so that represents about 20 billion just in hardware sales alone, okay? And there's about 700 petabytes of video recorded every day by surveillance cameras. Staggering numbers, right? That far exceeds, anything you would see sort of on the consumer side or YouTube or what have you. But now, that's where the opportunity is. If you look at the number of cameras or the percentage of installed surveillance cameras that actually use vision or have vision, it's minuscule, right? So under 5%, and that's my estimate, there's really no real data available about it. Maybe you guys are tracking it. But I believe less than 5% of the installed base uses or has any kind of vision technology. And I'm being somewhat liberal with the use of the word vision technology because most of them are doing nothing more than frame by frame pixel change detection. And then there's a even smaller fraction that actually uses advanced vision, okay? And by that I mean some of the things we have heard and we know about, such as classification and tracking and scene learning and understanding. So that's a really small number. Now, why is that interesting and why am I excited about it? It's because that means there's this massive untapped market that can benefit from all the advances that we are talking about here that each of the member companies are bringing to market. It's just there to be had. Very quickly, let me define some of the vision applications that you would see today in the surveillance space, right? and what they mean. So the simplest, and so just to step back a second here, vision applications in surveillance serve multiple purposes, but a primary purpose is to take away the workload from a human and automate it, right? So gone are the days, and certainly there are still movies that romanticize the whole notion of I got so many video cameras with this big wall and I can track everything, and there's these people, Superman or some whoever, right, standing there or sitting there, and they can keep track of everything that's happening. Well, that doesn't happen. So the whole premise is that we can automate the process of having to analyze video and find things that may be interesting for someone to look at. So the most basic of those is motion detection, which is simply pixel changes detected across multiple frames. And then they may have certain additional filters on top, which have to do with the size of the object, literally how many pixels is it, or which part of the image is it in. It's in the zone, so I care about it, versus that zone I don't care about, and or direction of movement, which may be a little hard to track if you're just looking at gross pixels, because especially with humans and articulated objects, that can change quite a bit. So it goes without saying it has a very high false alarm rate. It has such a high false alarm rate that it's pretty useless right now. But this is the part that's deployed within 5% of the installed base of cameras, right? Now you can make that a little better and go to the next step and say, okay, I'm finding these pixel blobs that are kind of changing on the scene. I don't know what they are. They could be leaves blowing. They could be, the clouds coming in and out, and shadows and glare and whatnot. I want to make that false alarm problem easier to deal with, right? So you could do it by defining lines or zones and saying, hey, now I'm going to start following that blob, and it's roughly the same size, and it crosses over this virtual line. Then it may be of interest because now they're on my property, or they're within the perimeter that I'm trying to protect. And so that's when I call it an intrusion detection event and tell someone about it, right? So that clearly reduces the number of false alarms. By design, you're just trying to say, I'm looking for a certain characteristic of how those pixels are changing. And that is used pretty widely today for counting in retail and other places where now you want to know how many footfalls there are in a retail store, or for traffic counting and things of that sort, where you can do that relatively accurately if your camera angles are right. Clearly, if you have camera angles like we see in most vehicle-mounted or head-mounted cameras, it's not going to work because everything's going to get mushed together. You really need a top-down camera view to be able to do that line crossing type detection. But it gets really interesting with advanced vision is once you start throwing classification into the mix. And so in order to do that, once you do that, you can say, hey, I see a person here, or I see an animal of a certain type, or I see a vehicle, and I can classify based on the type of vehicle even, right? So you can do everything you can do in the first three categories, but now a lot more accurately. You can say, you know what, I really don't care about all these leaves blowing across. I don't care about all these headlights sweeping through my property from the highway next door. I only care when there's a real person on my property. Can you tell me about that? And that takes that next level of vision capability, which adds classification to it. And now it'll tell you, hey, there's actually a person here, and that person's been there for a certain amount of time. And oh, by the way, there are two other people that passed by but did not stay on your property, right? So that's that level of sophistication. And then lastly, you can make that, take that to the next level. And I kind of threw this in this category of suspicious object detection, but more broadly, you can call it behavior recognition. One application that's been in high demand, but not easy to deliver on, is the suspicious object left behind, right? So if you talk to any, and again, even recent incidents as recent as this past weekend, I mean, things happen, bad things happen, right? And it's almost impossible today to prevent those incidents. But what if a camera were to be able to detect and say, hey, there's a bag left on the sidewalk, and it's supposed to be sitting there. So that's what that suspicious object detection analytic is supposed to do. The challenge with that is it's subjective to interpret. So what if I'm walking with my briefcase, I put it down while I try to pick up my phone and step away 2 steps. Is that a left object? Is it not? Does it still belong to me? There are all these, what if I'm throwing away trash? I mean, it's pretty subjective, right? So it can have false alarms or have misdetections. But clearly, I think by adding sort of the time dimension or the temporal dimension to the spatial dimension and some learning, I believe that is also a solvable problem. All right, so These can be deployed either in an embedded setting on the camera itself or on devices that are in close proximity to the camera, or it can be deployed on a server, which typically happens to be a PC, or in the cloud. And real quickly, let's look at where these are mostly deployed. So again, as processors have gotten faster and there's been more computation available at the edge, meaning on the device itself, we're seeing more of these capabilities migrate to the edge, but clearly they involve different levels of computation and complexity. Not to forget, okay, so that's the technical aspect of it, not to forget the cost and price element of it, right? With a PC, I can consolidate a whole bunch of these and process it all, sort of off camera. So those have been pretty popular historically. So if you look at server versus embedded, motion detection kind of, encompasses both sides. And then I also split it into indoor versus outdoor application. Motion detection does not work really well outdoors for the obvious reasons, because you're looking at pixel changes, and pixels change all the time outdoors, right? So it's mostly an indoor application. But there are some folks trying to do it in an embedded way outdoors. Similarly, counting historically has been more on the server side, because you're trying to do that across multiple cameras, and you just kind of consolidate all that with inexpensive cameras, pulling video into a server, and then you're processing that. Where it gets interesting, intrusion detection, a lot of embedded, and a lot of outdoor applications for that. And once you get into classification, some of those more interesting things, again, it's somewhat of a mix, but tends to be more server heavy. But I think that's going to shift upwards for the classification as we add more intelligence, add more vision capabilities to processors that are going in security cameras at the right price points, right? So let's look at certain trends. Sorry, apologize for that. That are affecting vision adoption and surveillance. So 2 years ago, if I had been talking to you guys about this, I would say, great, vision's going to be there and it's going to, completely proliferate. But actually, today I'm not as sure, and I'll tell you why. A couple of reasons why. The first part is my enthusiasm from 2 years ago, which continues to an extent today, right? So more and more IP cameras. IP cameras are cameras that basically are transmitting a compressed stream over a network, compared to the more historically available analog cameras, which are just transmitting an NTSC signal over a coaxial cable, right? So it was a point-to-point technology, in which case, in an analog camera, you typically did not have a CPU or a processor. You had a signal processor, but not a computational engine. So part two here, the second part, which is talking about the resurgence of analog video. So IP was taking off because everyone wanted to go high definition. Price points came down rapidly. And that created an opportunity to make all these IP cameras vision capable. Now, the reason people had to go IP was because that's the only way they could get high definition. Well, not the case anymore. Over the past 4 years, really, but 2 years it's taken off in the market, is folks have come out with signal processing chips that can transmit high definition video over point to point, right? And the simple reason for that taking away market share back from IP is that there's a massive amount of installed cable out there, okay? 90% of places that need a surveillance camera commercially today have one. They have one, right? Which means the cabling is in place, and certainly in places where labor rates are high, it's too expensive to pull all new cable. Cable's cheap, labor's not. So, analog HD over coax, I believe will slow down some of that, unless we can come up with an integrated CPU, ISP or signal processor that can help. And then lastly, the big trend, a huge trend, is the DIY. Jeff knows this. I mean, we started off at the CES, almost creating a category for DIY cameras. And today it's in fact, I remember meeting with Costco the first time, and they said, what are you guys trying to do again? This is what we're trying to do. Well, it's a big category for Costco today. It's a big category for Amazon, for Walmart, for Best Buy, for anyone, Home Depot even, right? So that's really emerging, and it's driving a lot of innovation and disruption. There's, probably a camera launching every week on Kickstarter, and they come and go, but it's exciting. It's really exciting, right? So I think that's going to drive a lot of adoption, and I believe a lot of that innovation is going to come from the residential side and then creep into the commercial side rather than the other way around. Because, as I've learned, consumers are a lot more demanding than industrial commercial users. Commercial users, if they're buying security, they either have a guard that's sitting there, hey, we're paying this guy, it's okay to have some falses. consumers not as much, right? So really exciting. I mean, on the IP migration is great, DIY is great, analog HD is kind of in the middle, slowing things down, right, from a market point of view. And again, of those 300 million cameras, the vast majority of those cameras are analog, right? So 90% or more are analog. That's where they are. All right, so now, how does vision apply to surveillance? Are we there yet? I wanted to answer that question. So while algorithms have been around, we don't need a lot more, or do we? I don't know. I mean, we talked about the different ways to classify HOG, part-based models, as well as neural nets. So we'll cover that here in a second, but there are certain things that matter for surveillance that make it different compared to other applications of vision, whether they are, in automotive or in AR, VR type environments. The number one problem in my mind is sort of camera placement, right? With surveillance, you're trying to cover big, vast areas, and you're trying to get constant recording in those areas. So you're trying to minimize the number of cameras for the maximum coverage, which means you're going to get objects that are tiny, okay, in a lot of cases. Or you're going to be too close and miss most of the things you want to see. The other interesting and challenging part is the clutter from environmental factors, right? And how do you deal with that? Occlusions make it difficult to classify things from a single image because you may not see the whole object or the whole person. And lastly, and also really important, is illumination. A lot of surveillance video matters at night when it's dark, and that video looks very different. I'll show you some examples. All right, so I try to compare this to automotive and look at some of the data sets we have with classification that's been done for automotive. So the camera is sort of at vehicle height or at person height. So you're getting sort of this view of the person that's at about 3, 4, 5 feet from the ground. Surveillance tends to be a lot higher. So you're kind of looking top down if you see the images at the bottom. The angles tend to vary quite a bit compared to, if it's a car-mounted camera or vehicle-mounted camera, you're going to get a frontal view. But in surveillance, you get pretty much anything you can imagine. And it's got to work day and night. The quality in surveillance tends to be lower. Now remember, 90% of what's installed out there is analog NTSC cameras. The best it's going to do is 480i, okay, not 1080p. And that's a big difference. So you don't get that quality, and you're looking for that massive amount of range. Let's take a few more examples. So again, a lot of examples that we see, everything we see in the research community, or most what we see in the research community are coming out, is daytime images. It looks very nice and pretty, and we go like, yeah, cool, that's okay. We know how to deal with that. But try dealing with this, right? So the first one there is really poor contrast. We actually did pick that up. You can have a tiny object, so maybe a real quiz here. On this one, would you be able to tell where the person is? It'd be hard. I don't know if it's big enough, but there's a tiny little red box up here that says where the person is, and the camera picks it up. Another one here, clutter and occlusion, right? I mean, try to train a feature-based classifier on something like this. There are tons of edges in this video here. And so I'm just going to play it, see if you can actually find the person. You'll see motion cues will help you, but there actually is a person in that video. You probably saw them right now. But the point is, the camera and the vision technology in that camera has got to pick that person up with that kind of view, all right, at that resolution. That's 320 by 240 video, right? That's the best you can do. And then there's weather we got to deal with. So here's an example where you get weather like this, and this is what it does to the video. And you can see it's raining, and there's lightning, and it just goes crazy. And that comes back to camera and imager and ISP tuning. For vision, what we have found out, I mean, most security cameras and most cameras for consumer use are optimized to create the best image quality. Guess what? It doesn't work real well in these kinds of environments because it creates these fast changes. The camera starts reacting with exposure times and whatnot much faster than the vision algorithms would like it. It creates artifacts that you've got to react to. So you can get false alarms, and that's bad too. People lose faith in the system. All right, so if you look at pedestrian detection algorithms, you look at the state of the art, right? I mean, there are clearly these two different categories. We talked about that a little bit earlier. There's the feature-based methods, which are sort of handcrafted features. And that was the historic way of doing that. And there are a couple of nice papers on that. There's a paper by Dollar in PAMI 2012 that shows how well these do. And so if you look at the best of them, you get about a 22% miss rate, if you will, at one false per image, right? If you look at deep learning, it's gotten better than that, but it's roughly in that ballpark, right? And these were both on the Caltech pedestrian database, for those of you that are familiar with that, 640 by 480 camera, right? So it looks like 20% miss rate with a 10% false positive today is state of the art, okay, for classification. And the question I would ask is that sufficient for surveillance? Well, do we have an analogy in maybe from a different market? To me, that's the equivalent of saying, hey, I'm trying to make a phone call, and you know that 20% of the time, that call will not get through. And 10% of the time, it'll ring the wrong number. Would any of us buy a phone or a service that did that, ever? No. Well, guess what? That's the state of the art that Vision's providing today. Jumping to the conclusions here a little bit, but there's a lot to be done to get where we need to be from a Vision point of view, right? A different way to look at it is say, hey, listen, I'm trying to break in somewhere. I know the best Vision technology has been deployed. Great, my mission's possible. I'm just going to go right through, and no one's going to find me, right? That's where we are, truly, right? Or are we? Well, the question to ask is, what is the gold standard? How well can a human do? So let's pretend that I have a person that can watch each and every surveillance camera all the time, and they are alert and vigilant all the time. What can they do? And so in fact, there have been studies, and so a human observer has about a 5% miss rate and an 8% false alarm rate, right? So there's always a trade-off. If you miss more things, then you have your false alarm rate go down, and the other way around. So the question is, can we do as well as a human observer can, or better? Okay? Because a lot of folks, and we've been in the market a long time, we talk to a lot of what I would call pretty tough and unforgiving security directors. Not having a breach on my watch is basically what we hear, which I completely get and understand and appreciate, right? Well, sort of being out there in the real world with real applications, the good news is that a lot of the classifiers that you see results on are looking at a single frame or a few frames. By using multi-frame analysis and a hybrid approach that combines handcrafted features with learning to augment it, you can actually do better, and we actually are. So I'll give you some examples very quickly. I'll play this video in the interest of time, but these are real examples of apprehensions, and I think I was talking to someone over a break. Look at our website, I'd forgotten about it, but one of our customers had their 110th apprehension with our cameras. But this is a car lot, the person's trying to break in. That's really what the image looked like, right? And the camera is picking up the person on the lot, and then the cops get dispatched. You'll see them coming in right there in the bottom left. And then the last video you're going to see is the court walk. So 3 different cameras, as you can see, but in each case, within minutes, first to pick up the person, that created a dispatch, the cop showed up, and they made an arrest. So just one example of how successful it's been. This is a second example here. I'm going to skip that here in the interest of time. Let's see if I can do that. There we go. And the last was the one I showed you earlier, where the person was actually attempting to steal a bunch of tractors and was arrested as well. So that's where the proof is in the pudding. Does this stuff really work? The short answer is yes, but there's still a lot of work to be done. We're not there yet. All right, so where do we need to go from here? If I look at where we are and where we need to go, and sort of look ahead to the next 10 years, I'm less inclined to say that there need to be improvements in algorithms as opposed to improvements in systems and system design and tools. So certainly we need improvement in classification and detection accuracy. I believe that'll happen. We are on track to do that. It's super exciting to see everything that's coming out of the research community in Vision. So I'm betting on that happening. What I'm not betting on, and which I wanted to appeal to all of you here, is number 2 and number 3, right? For surveillance, the real important thing, something we struggle with a lot, is that low light sensitivity. You saw the images, they look terrible, right? Any kind of ambient lighting changes completely throws things off. So whether it's headlights going through or lightning, or it could be anything, right? And so we really need that massive amount of order of magnitude improvement in imager sensitivity And I don't know if you'll get to this, but I threw some numbers out, right? And one way to measure that is volts per lux second at a certain resolution. What's happened is as the resolution is going up, it's physics, right? And the amount of light collected by each pixel is lesser, and so the overall sensitivity is actually going down. And in fact, we still have cameras that are VGA resolution that have better light sensitivity than ones that are doing 1080p or 4 megapixels. And that's kind of almost going in the reverse direction. They create a fantastic image, and there's a lot of talk about face detection and face recognition. All that is good and great in an indoor application when I'm passing through a door or a portal. A lot of security is not deployed that way. It's deployed in much wider settings, and it matters at night. I mean, if there's something bad happening, it's unlikely someone's going to go, yeah, just go walk in front of this camera and say hi, right? So anyway, we need that big improvement in low light sensitivity without sacrificing the resolution. So we need both. And maybe I'm asking for too much, but I would love to see sort of innovations at the materials and devices level that would make that happen. So I'm firmly a believer in garbage in, garbage out. The vision algorithms got to work a lot harder the worse that the input is, right? And then we just had this talk about power consumption, so that's very timely. System power consumption is a big challenge today, right? And it's sort of a double whammy, because not only do we have to expend power on the camera, the imager, ISP, and the CPU and vision processor, we actually have to spend a lot more power on illumination, okay, which is it's about 4 to 5x of what we spend on the camera itself. We're spending on lighting up the scene, whether that be with infrared or visible light. And so what that means is cameras can't be portable or battery powered. That's what it comes down to. And till the point that they are battery powered or portable, they're going to be tethered to that cable, and that's just going to slow things down from a deployment point of view. Really, I mean, if you project ahead, everything around us should be attuned to us, and there should be vision in everything, so it'll sense that, hey, there are 4 people in this room or what have you, but that means every room's got to have a camera or more than one camera. That's not going to happen until we get to these innovations, right? Till we get to these improvements in both power and sensitivity of the imager itself. Today, I would say where we are for just the camera subsystem, which is the imager, ISP, codec, and vision, I think we could do it in about a watt of power, all inclusive, but not including the illumination, right? So you do need that low light sensitivity. So we have a lot of improvement necessary there. All right. What's next? Very quickly, there's a lot of possibilities. We hear a lot about drones. A lot of you are working on that. Body-worn cameras are certainly getting more and more popular. We talked about face recognition, and then there's AR for security investigations. I think we covered some of these topics earlier. From a business point of view, I think it's still going to be a while till these things catch up in any. Drones clearly are used, right? But today they're used for doing surveys where someone's going and watching that video later, after the fact. We have some detection technology built into drones now that'll post-process that data or process it on board itself, but it's pretty rudimentary today, right? And that's got to get better. Again, there's an endurance problem with the drone and a range problem. We all know that. And the less the vision system takes, the more room we would have for everything else. Body-worn cameras I'm excited about. It's similar to the ADAS problem. That's something I look forward to seeing more solutions with. Face recognition just needs to happen at scale with passive subjects. What I mean by that is, as my face has been recognized, I don't have to actively cooperate with my face being captured under specific lighting conditions or in specific angles. It should just work at scale in all kinds of environments. I know we are working on that. And then lastly, I believe augmented reality to help a security officer actively investigating something by overlaying things in their field of view as cameras detecting them would be very helpful.